At the point when we inspect the giant span of the universe with its planets, stars, and cosmic structures, a valuable inquiry emerges: for what cause is there some distinctive alternative from nothing? This puzzle turns out to be a great deal more confounding when we bear in mind the balanced legal guidelines of cloth science governing our universe, where matter and antimatter have all the earmarks of being similarly adjusted. Yet upon perception, we tune down that the stars and worlds we see are overwhelmingly manufactured from matter, with almost no antimatter present. This leads us to contemplate the unpredictable forces that ended in this lopsidedness, bringing forth the universe as we see it. What sizable gadgets influence the scenario and INUTH as a universe overflowing with structures, stars, and the secret of our personal fact? Hundreds of years previous, researchers regularly occurring the universe existed in a perpetual shape, represented by using an impermanent la guidelines of cloth technological know-how. However, in 1927, a Belgian minister and researcher named Georges Lamra proposed an alternate concept. He endorsed that the universe started out as an big, pregnant, and early-stage iota that detonated, bringing forth the extra-modest debris we see today. Notwithstanding the fact that his thought at the beginning slipped via every person's notice, cosmologist Edwin Hubble's disclosure in 1929 that the universe is extending gave help for L's concept. Following this disclosure, researchers pondered that if the universe is extending, it'd have to have all started from a minuscule thick point. This idea changed into cleverly named the principle of prehistoric cosmic detonation by stargazer Fred Hoy, a time period later embraced by its advocates. In the mid-1960s, cosmologists Arno Penis and Robert Wilson accidentally discovered evidence assisting the Big Bang speculation whilst endeavoring to tune into microwave signals from the smooth manner. They coincidentally determined a persistent foundation commotion, which ended up being the grandiose microwave basis radiation, a leftover of the Big Bang. However, how did the Big Bang result in the arrangement of planets, stars, and universes? Through fastidious estimations and perceptions from telescopes on the planet and tests in space, researchers have fashioned a powerful rationalization. Kind of pretty a while ago, all the count in the universe rose up out of a solitary factor or peculiarity in a savage eruption of power. This fast improvement, referred to as expansion, made space and the crucial forces of nature internal parts of a second. Electricity changed into particles of matter and antimatter, the general public of which demolished each other. Fortunately, a limited amount of problem may do at last forming protons and neutrons. In the space of minutes, these particles began to intertwine, making the nuclei of hydrogen and helium. Over the long haul, debris fashioned, filling the universe with billows of gas. Later, around 380,000 years, the astronomical microwave basis radiation was abandoned, containing little waves of remember that in the end developed into worlds and cosmic bunches. Today, our perceptions of the universe, mixed with logical headways, paint a consistent photo. Our universe is prevalently made from remember, keeps the legal guidelines of bodily technological know-how, and has evolved north of billions of years from a uniform ocean of hydrogen and helium. It has modified into an organized universe loaded up with universes, stars, planets, and certainly even smart life. This extremely good mission from straightforwardness to intricacy stays is an indication of the wonders of huge development and human inventiveness. Starting from today, we are able to trace lower back in time and ask about the beginnings of each person's structure or a part of the universe. With each answer we get, we will dig further, asking how and wherein it emerged until we come to the point wherein our comprehension fails us, wherein we are restricted to concede we don't know. Yet then, at that factor, we are able to bear in mind what we do understand and question how it became, considering if there is a probable way it would have risen up out of nothing. The existence we encounter nowadays comes from little debris making the whole lot around us. These debris move approximately as constructing blocks, assembling into complex particles essential for existence. On the maximum central degree, those building blocks are molecules, the essential elements associated with all matter inside the universe. However, atoms did not suddenly display up at the universe's initiation. Rather, they went via a drawn-out direction of improvement. This cycle includes the life sample of stars, start existence, and loss of life. When stars arrive at the end of their lives, they produce new substances through stable reactions. These material add to the association of latest stars, maintaining the cycle. This inestimable recycling is essential for the presence of divine bodies like planets and the multifaceted technology essential for existence. For the universe to have stars and systems as we noticed today, some basic variables needed to adjust. Gravity assumed an essential element in conglomerating extra-modest heavenly and cosmic groups into larger designs. Additionally, the presence of dull matter in the universe's beginning phases forestalled the deficiency of matter into area during superstar development. A fragile equilibrium of diverse types of difficulty in radiation changed into essential for peculiarities just like the good-sized microwave foundation and the association of cosmic systems. Besides, slight sorts in issue thickness, improved by gravity over the lengthy Hall, were tremendous in forming the universe's design. These beginning irregular characteristics, mixed with the upward push of dull remember, or regular matter, established the basis for all that we see. The mystery extends while considering the remember-antimatter balance. Even as bodily technology obviously treats remember and antimatter similarly, our universe displays an extra problem. Special factors should constitute this difference, for example, particular instances during the universe's development, offbeat cycles defying general norms, or cooperations inclining toward the advent of problem over antimatter. The trendy model of material technological know-how consolidates these mind. But it falls brief of giving a complete explanation. Likewise, dull remember poses a trouble, regardless of not being formed of trendy model debris. Its presence is surmised via various perceptions. The origins of dull matter remain dubious, with speculations going from its creation throughout the early universe's warm degree to its development as a result of gravitational interactions. While we've made big steps in expertise the universe's moves, many inquiries persevere with appreciate to its beginnings and peace. Investigating these secrets drives logical inquiry, pushing the boundaries of our perception, and inspiring new roads of exploration. They've probably been a gadget to create the energy anticipated for the universe's presence whilst it failed to beforehand exist. As consistent with gross expansion, are using speculation regarding the universe's pre-Big Bang beginnings. The truth that this strength makes it manageable commenced from nothing. Even as imagining the beginning of the recent big explosion, we typically envision a situation of outrageous heat thickness and energy. Presently, thinking of how this kingdom regarded, we move up against viewpoints. Right off the bat, we ought to basically state that the universe became added into the arena, thusly with the underlying conditions set as such, missing in addition rationalization, a function that some may also portray as giving up in the area of hypothetical bodily technology. Alternatively, we can include the extra willing in the direction of approach among hypothetical physicists, identifying a speculation to clarify these underlying circumstances. This entails making forecasts that go off course from the ongoing stated speculation and therefore exposing them to actual checking out. Infinite growth originating from this remaining alternative approach disappointed how we'd interpret the universe's advent to the sector. As opposed to imagining the hot and thick beginning as a vastly little limitlessly warm factor, enlargement locations a pre-Big Bang level where area itself encountered an honestly high power thickness. This fast extension of the universe at some stage in growth finished within the alternative strength into matter, antimatter, and radiation. Consequently, bringing about the outcome of the hot giant detonation. Furthermore, enlargement not just yields a universe defined by using uniform temperature and a level look. However, moreover predicts express thickness variations consistent with perceptions from a situation of nearly void space immersed with electricity. A normal interaction has coordinated the development of the entire discernible universe, loaded with its diverse structures. However, how and when this idea offers a resounding machine for figuring out the universe's beginnings, it cannot satisfy everyone. The concept of a universe absent any trace of area-time and the laws of material science can challenge to conceptualize. From a philosophical outlook, one could ponder domain names beyond life or situations unconstrained through actual reality. Deductively, there are special tactics to symbolize nothing, each legitimate within its particular context. These definitions range from when something did not exist to the emptiest country of space-time with the lowest electricity. While we can verify that we've stepped forward from nothing to a universe, making use of certain definitions, others present more vagueness. In the end, the situation of the universe as bobbing up out of nothingness stands as much as the constraints of our present-day logical comprehension. While quantum hypothesis recommends the danger of universes emerging from quantum changes, experimental proof remains slippery. Consequently, even as the opportunity that our universe upward thrust up out of nothing holds provider, it calls for similarly investigation and validation within the shape of theoretical inquiry. Enter Donan He and his organization from the Wuhan Institute of Bodily Technology and Math, who have made a noteworthy contribution by supplying the first numerical verification that the considerable detonation may without a doubt come from quantum variances. On the core of this leading part lie basic ideas, the Wheeler-DeWitt circumstance and the Heisenberg uncertainty well known. The Wheeler-DeWitt circumstance, added about by John Wheeler and Bryce D.T. throughout the 1960s, addresses a crucial headway in the assignment for a hypothesis of the entirety, mixing quantum mechanics with preferred relativity. The Wheeler-DeWitt equation represents a crucial advancement in the quest for a theory of everything, merging quantum mechanics with general relativity. This equation attempts to describe the entire universe in terms of quantum wave functions without the need for a separate time parameter, suggesting that time itself may be emergent rather than fundamental. However, the interpretation and application of such concepts continue to challenge physicists, prompting ongoing debates and refinements in theoretical frameworks. Moreover, understanding the origin of the universe from nothingness remains a profound philosophical and scientific inquiry. While quantum fluctuations and inflationary theories provide plausible mechanisms for the Big Bang, the ultimate cause of these initial conditions and the nature of existence itself remain elusive. Each attempt to theorize about the universe's origins confronts the limitations of human understanding and the frontiers of scientific inquiry. In conclusion, the exploration of cosmological mysteries not only expands our understanding of the universe but also stimulates new avenues of investigation into fundamental physics and philosophical inquiry. The journey from simplicity to complexity in our comprehension of the cosmos underscores the remarkable achievements of human intellect and the persistent quest for knowledge about our place in the universe. The quest to unravel the mysteries of the universe's origins challenges our very notions of existence and reality. From ancient philosophical inquiries to modern scientific theories, each attempt to explain the cosmos reflects humanity's relentless pursuit of understanding. Whether contemplating the possibility of a universe arising from quantum fluctuations or grappling with the concept of nothingness itself, these investigations push the boundaries of human knowledge. Moreover, as we delve deeper into cosmology and theoretical physics, we encounter profound questions about the nature of time, space, and the fundamental laws that govern our universe. The journey from the hot, dense state of the Big Bang to the formation of stars, galaxies, and life itself underscores the intricate interplay of cosmic evolution. Yet, amidst the complexity and uncertainty, there is an enduring fascination and wonder about the universe's grand design. Each discovery, whether confirming existing theories or challenging established paradigms, enriches our understanding and inspires new avenues of exploration. Ultimately, the exploration of cosmic origins is a testament to human curiosity and ingenuity, driving us to seek deeper truths about our cosmic home and our place within it. As we continue to probe the mysteries of existence, we embark on a journey that transcends scientific inquiry, touching upon the very essence of what it means to exist in a vast and evolving universe.